Good morning, everyone. This is print reading for construction. We are going to go over Unit 8, Site Plans. So our learning objective will be to recognize common features of site plans, identify property line descriptions, and explain the difference between True North and Plan North. And then be able to read contour lines on a site plan, and then plot topography sections. So let's begin. So technical terms, these are words that are very common, that would be used in common vocabulary when you're talking about working with your site plans, when you're talking about developing your project site, your property site. So you have what is referred to as the assumed benchmark, and then bearing. Bearing has to do with directions in terms of an angle. You have a benchmark, which is a reference point. You established a reference point. So an assumed benchmark would be an assumed reference point, and then a benchmark would be an established benchmark, like a finished floor height or the top of a landing to a set of stairs, or the elevation at the bottom of the stairs, or the elevation at the first floor. Contour lines. Contour lines is what you see on a topography map when you're showing that on a flat piece of paper, land that has various shapes, right? Different elevations. So contour lines will show a certain elevation, and they will move relative to the shape of the land. Delta is a term used in mathematics. It means if you use D for difference, the delta would be the difference. So that's what that means. Now, an easement is like allowing objects to be on your property. You might have a road easement going through your property, which means that a certain designated area might be dedicated for a driveway, and maybe you have to share that driveway with the neighbor behind you, and therefore the driveway may be your property, but you have what is referred to as an easement, which allows other people to have access to that driveway. And usually that's a legal arrangement. So when you have an easement, you cannot encroach on that easement, meaning you cannot block that easement or that driveway. It's supposed to remain accessible to shared people to share. For example, you might have a telephone pole or an electric pole that's at the back of your property. There'll be a location that's called an easement, like maybe directly underneath the lines, the electrical lines, or directly underneath the pole. And so in your easement, you might have a PG&E easement that says that PG&E can get on to your property to access that line. A legend is a set of symbols with an explanation. So you might show you what a dotted line represents, a solid line, what its meanings are, or symbols, a particular shape will tell you what that symbol is going to represent on a legend. Now, a minute is a unit of measurement with direction. So we have degrees, and then we have minutes. So like a clock, we have minutes, and the needle moves around. So you have degrees from one number to the next number, and I believe the the distance between solid numbers of degrees is the minute. So it's a little finer direction. Plan north. So planned north is just north, like you'd say east, west, north, and south on a paper, and you establish, say, the top of the plan is north, although its true north, not like with a compass, might not actually be in that same direction. The plot plan is the plan. Well, what we're talking about, a plot plan is the site, the whole area that we're working with. So the plot plan will show the whole property, the property lines, and which will be around the perimeter of the property. Usually it'll show you the street names. Sometimes it'll show you the property next door on the left and right of you, and also perhaps behind you. So site plan or plot plans will show you your overall general plot. Property lines, I mentioned that earlier. That is the line that represents the limits of your property. So from one individual who owns the next property lines. So property lines will meet. You will meet at the property line of your neighbor. So you might share a property line with the neighbor to the left of you. You may share a property line to the neighbor behind you and to the right of you. And then maybe your property line in the front goes all the way to the sidewalk or the street. Second, I'm not sure what second means. We'll find out. Setback. Setback means that you have a limit. Things cannot be right on the property line sometimes. Like if I were to build a building, the building has to be set back from the property line. So I'm not too close to my neighbor on my left and my right side, or I'm not too close to the street in the front, or I'm not too close to the property line in the back. So when you're establishing where your building is going to be placed, minimum setbacks are something that one would take into consideration because building code says that you cannot be right up against the property unless you're doing something, you have a special reason or special condition to be able to do that, an exception to that rule. Otherwise, having proper setbacks provides space between houses or buildings so that one building, should it catch on fire, would not necessarily put the neighboring property in jeopardy. Site plan is very similar to the plot plan. The site plan shows your particular site, where a plot plan will show the shape and the contours of the property. So a plot plan might show that your property is on a downward slope and there's various elevations, and there'll be marks that will show the topography. And the topography is the measurement and the lines that establish the shape of the land. True north is what is north from a compass. If you were to grab a compass and the compass would point at true north, or I believe they call it, there's magnetic north and true north. So we'll have to establish if there's a difference. But when you hold a compass and it points to north, it's pointing to magnetic north. And then, but I think then there's the north that's established on a map, which might not be exactly on magnetic north. And then zoning. Zoning has to do with an area that might be established with a zone, like a residential area zone or a commercial area zone. So you wouldn't see your townhouse right next door to the mall, or in between two buildings that might be like factories. Usually areas are zoned for industrial uses, commercial uses, residential uses. So depending on the type of area that area has been planned for by city planners, then it would be under a particular zone. So here's an example of the site plan. It's a view from above the property. And like I mentioned, it's sometimes called a plot plan. So a site plan and a plot plan, very similar in that it shows you, as you can see here, this is the cul-de-sac of a street. These where it says C22, C21, 20, 19, 18. Well, those are the frontage of these plots or these lots of land. And you can see they're identified on a map. And that's what a site plan is. It's basically a portion of a map. You can see here in green the lot number. It doesn't have an address yet, but it does have a lot number established on a plan. And then that lot number, you can see, has 106,253 square foot. Pretty big property. And then, or it's in acreage, 2.4392 acres. So, not quite 2.44 acres. And you can see here that they've got dimension, length of dimension and bearings. So this is the property line. You can see it's got little circles at the corner. And this number here, 65.84 feet, is saying that's 65 feet from point to point. Here, it's telling you that this line is 640.93 feet in length from point to point. And it is traveling, that line is on a particular angle, or what is referred to as a bearing. And so with a compass, one would know that this line is north 15 degrees, 38 feet, 47 minutes. Something like that. That's how it kind of reads. I might be reading it wrong, but that's the general idea. And so you can see, it's a surface drainage easement. So this area has been designated for like a low area, and you can see it kind of crosses between other properties. So drainage, water can drain in this direction and meet in this little low spot. From the back, it meets in the low spot, and then it moves its way and travels down this little established corridor or a little valley. So it's just an area that's been shaped by the person who established the map and designed it, the property. Here you see where it says rear yard setback typical. So this dotted line that's off of the back of the property is that rear yard setback. You can see that there's another dashed line that's a setback from the side of the property. So site plan features, you have the lot and the block numbers, or an address. In this case, we didn't see an address. You have bearing with this direction and the length of the property lines. You saw the north arrow and dimensions of the front and rear side yards. Let's go back and take a look at the north arrow. Do I see a north arrow? There is not a north arrow on here, but most plans would have one. Dimensions in the front, rear, and side yards. Yes, we saw those dimensions. They were also, the dimensions were the length of the lines and then also the bearing or the direction of those property lines. Trees and shrubs to be removed or retained. So the site plan would show features of existing trees that you would want to keep and trees or shrubbery that's going to get removed. Grade elevation and topography. So it's showing you the shape of the land in a site plan, and you would see dimensions that would show the changes in elevations and those locations of accessory buildings might be a garage, a carport, or some kind of mechanical building. So plan north. So there's plan north and there's true north. If you can see here in this map here showing you the north arrow, you can see plan north is just vertical, like the top of the page, where true north is slightly at an angle of 21 degrees. But it may be used if the building walls are not parallel to the compass direction. So see, this is at a slight angle. True north is at a slight angle, and if your building is not going to be actually at that angle, then perhaps and be positioned, square on your paper from left to right, then plan north would probably be the best use of an arrow, direction arrow. So they differ slightly from true north, and usually they're identified on plans. So you can grab the compass and see where true north is, and then know that your building may be slightly off from true north. And so these are different writings or illustrations that we would see on plans. As you can see on this foundation plan, it shows north being to the left side of the page. See, there's an arrow there. Here you see another architectural site plan showing you the scale, and here it's showing you an arrow that north is off in that direction. Down below, this is another way of a north symbol. You see it's got a cross hatch, and then north is written on a specific line, you see. And then under this parking level floor plan, you can see it says a general arrow. So different ways that the arrow is used. Site plan features. Let's see, did we already do this one? So in terms of bearings, going back to that site plan, you can see there's the north arrow pointing off in the direction straight to the left. And then you see here N42 2836 west. So this is showing you north 40 degrees, 28 minutes, 36 west. I'm not exactly sure if I'm reading that properly, but that's the general idea. And notice here is the lot number identified. Over here is the curve number, referred to the table for curve information. So there would be a table on a set of plan It'll give you information about curving, right, at the street. And like I said, you can see other things like utility information, drainage. TYP means typical. You see some setbacks. So bearings, property lines defined by length and bearings. So it tells you the length of the property line, and the bearing indicates the direction of the line. So bearings are expressed as degrees east or west of north, or south in degrees, minutes, and seconds. So degrees east or west of north or south in degrees, minutes, and seconds. So you have degrees, minutes, and seconds. So between degrees you have so many minutes, and then between so many minutes you have what is referred to as seconds. Yes, it is a kind of a reference in time, and somehow that's a factor. So we can see here on this bearings and curves chart that you see C19 refers to the curve number. So I can come over to C19 and see some of the dimensions, like 60 feet is the radius of the curve. So from the center point, probably from here out 60 feet. See, there it is, 60 feet radius. So it's showing you exactly how to pour the concrete for the curve, or where the limit is from the curve from an established center point. You have an arc, which is also in length. Then you have the chord, which is from point to point. I think a chord is like from one point to the other point on the inside of a circle. And then you'll see that the chord bearing, because that's a straight line, right, from here to here, that line is at a particular angle. So it's telling you that the chord bearing is traveling at north 29 degrees 11 minutes 43 seconds west. So the line is traveling in a north direction, and it leans to the west side. It could be east or west of north. So basically it's establishing that angle. So contour lines identify the ground elevation. So the ground is not always flat. It might be up on a side of a hill. So the ground elevations at different points along a single contour line have the same elevation. So if the line is moving and changing shape, it's still at the same elevation. So it's trying to stay level, moving around, and it changes shape because the ground is going up and down. But the shape follows that same elevation. And so when you look at contour lines, you can see where the peaks of a hill are, or where a hill or a valley, a low spot. So the intervals between contour line is changed in vertical distance. So from one line to the next line, you could have spaces between one line to the next line, and it could be in intervals of a foot, 2 feet, 5 feet, and 10 foot. Those are the most common intervals. So the spaces between the lines show that the elevation from one spot to the other could be a foot higher or 10 feet higher. So these are examples of contour lines. You see how they move and they change shape. They change shape, but they're following a certain elevation. So if you kind of look at this, you can imagine that this is the top of the hill, and this is a higher elevation. Let's call it 20 feet. And then this line could be like 18 feet. And this line could be 16 feet. And so you see how they almost look like a hill. It's forming a hill going downward in the slope. So it's showing you this shape, and the lines showing you how the land is dropping in elevation. So you can see how these lines are closer together and these are more spread apart. Well, that's saying that the land is dropping faster as opposed to dropping slower. So here you can see a peak, like a hill, looking at it from the top down. And those lines can be transferred into a section. So this line is a section. Notice the line goes that way and that way. So if we were to slice across the peak of this hill, but we find that it's actually not a hill, it's a valley. So this is not the tip of a hill. This is actually the low point. As you can see down here, 884 is this line, okay, which is basically the bottom, as opposed to over here, this outer ring represents 900 feet. So you can see down here is 884 in height. So this line is a section showing you what it would look like. And so you see here how all these lines are close together. It's showing you that this hill is dropping down really rapidly. And then over here you notice that these lines are a little bit farther apart. Even this one spread farther. It's almost like the land is a little bit flatter. So you go from one line to the other, and these rings show the change in the elevation and height. So you can see here that this is not an actual hill. This is an actual hole, or like a valley, right? So you can see it dropping down and going back up. So that's how contour lines can establish or show you how the shape of the land. Green building, working with existing vegetation. So you've established a property, you have a property, you're going to build on it. Are you going to take a tractor and just scrape everything off the land? Are you going to destroy the natural trees that have been there for hundreds of years? Or do you plan on working with the existing vegetation? Do you plan on tearing out all of that vegetation and then putting in your own landscaping and making it look like a golf course? Or do you plan on keeping it original in the sense that the plants that are in your yard and you're using as your landscaping are natural to that region? Do you have to go buy plants and bring them in and have them, or can you use the plants from the surrounding areas? So working with that from the natural surrounding is a way of green building, sustainable. So constructing the building around existing vegetation reduces the impact on the natural surroundings. Possibility to relocate existing trees or take precautions to prevent potential damage. So you might move plants and vegetation around them to keep them. You might save that money. You might not hurt the land by introducing species that are not part of that region. So here's contour lines with elevation numbers. So when you look at these elevations, if you look at both pictures, they're both a circle with rings. But see, one indicated a valley or a hole. One indicates a hill. Yet they both look exactly identical in shape, except that the rings have different dimensions. So where the outer ring starts at 894 feet here, and this outer ring starts at 884 feet, oh, pardon me, the 894 feet is at the peak, the center. Here's 894 at the inner ring, and yet here's 894 feet on the outer ring. Okay, so notice that these numbers get smaller and smaller as you go towards the middle, indicating that the land is dropping in elevation. Here the numbers get larger and larger, indicating that the hill is getting higher in elevation. And again, notice how these lines or these rings are closer together. They're showing a steepness in the hill. As close as they are, they're changing in height quickly. And where over here these lines are spread out, so the land is a little bit less of a slope. See? Steeper slope, shallower slope. Here's a residential site plan. It's showing you the whole property. It's showing you some property setbacks. So this line here within the outer line, this is the property line. And then these are the setback line, just saying don't build within that space. Then here looks like an indication like this is some sort of creek or valley. If you look, there's the contour lines. You can see the shape of the land swooping around. It's almost like this house is on the side of a hill and the land swoops this way or sweeps down into this little valley, and it says Woods Creek. Yes, so this actually indicates the low spot, and you can see the change in the contours of the shape, that they're all leading down towards this creek. So at the bottom, going right the bottom of this valley or this hill, there's a creek going right through the corner of the property. It's kind of cool. Benchmark. It's a reference point to a permanent marker of a known elevation, right? The benchmark could be a survey marker plate, could be a fire hydrant, it could be a manhole cover. So when you look at a site plan and you get it from the city, somebody had established an elevation, and from that elevation, from that marker, your property line was established, and an elevation was also given, and it was measured from a benchmark. And so when you see a number, that number is referenced to sea level, or it's referenced to a benchmark, a known location that we're going to call 0, or some reference point. So there might be a plate or something that's been like a brass disc or a plate that's been laid on the concrete and attached. There might be a fire hydrant that has been established at a certain elevation, and a map will tell you that this fire hydrant at the top or the bottom or a certain point on the fire hydrant, there'll be a benchmark which says that from here we establish a measurement. So now when you're going to be doing your measurements, you will use that benchmark to continue your elevations. So all elevations on a given plot reference this point. So it's saying, okay, I am 10 feet. 10 feet from what? 10 feet from a benchmark, some sort of reference point. So it's important to know that, so that you can have your own benchmark on your property, and then maybe drive a stake, set the level, and then know that as a certain measurement from that benchmark. All elevations on a given plot reference this point. Architects may set the elevation of a particular point to 0 or 100 feet, called the assumed benchmark. So, like I said, they may call it 0. So everything's being measured when it says there's a number, say 10 feet. 10 feet from what? 10 feet from 0. Where's 0? 0 might be the fire hydrant, might be the manhole cover out in the street. Okay? And so if that's 0 and you're at 25, that means you're at 25 feet above that manhole. So maybe at the back of your property it's sloping downwards towards the street. It also establishes when you have limits, like the limit if you can build your house. They may say 2 stories with the top of the roof or the elevation of your roof to be no more than 35 feet. So 35 feet from the ground, right in front of the house? No, probably 35 feet from an unknown benchmark on the property. So these are examples of elevation benchmarks. So you saw that in some of those previous plot plans that we had little symbols in the corners where the property lines meet. So here's a property line. Here's a property line, and they meet at this corner. One of the side plans showed a little circle here. So these could be the different circles, and it's telling you that point, that circle, is at an elevation of 741.22. Or here, it's saying positive 741.22. And that's the finish spot elevation. Okay, and then you have a property corner with a monument. So a monument is a marker that's actually been put there, like a pin or a stake or something. And the stake is established at a certain elevation. Or here, an iron pin can be placed at the corner. And then you'll see this benchmark. We'll say BMX 869.75, or these are basically the different symbols, right? And so these numbers will establish that this is a benchmark at that height. It could be a measurement taken from sea level, and then we're calling it 869.75. And then you see from 869.75, there's 868, 870. So 869 is very close to 868, which is probably right there in that little corner. Green building. So rainwater harvesting, being able to collect the rainwater and reuse it again. Buildings consume an immense amount of resources, electricity, natural gas, and water. So being able to install a low volume fixtures to conserve water is good. Or being able to use rainwater for irrigation and landscaping. Having rain barrels or storage tanks or cisterns. So normally your downspouts or your drains would just drain right onto the ground and the water would just dissipate into the ground. But you can set up barrels or have storage tanks or have cisterns, which are underground tanks that will collect that rainwater and store it, and then be able to have some sort of piping system that will use that water at a later time for watering your plants. Right? So you don't have to pay for city water to get used. So topographic features. When we see a map with topographic lines, they'll be identified on a legend with symbols. And so natural objects would be like trees, Shrubs, human-made objects could be like utility poles, railroad tracks, fire hydrants, parking spaces. So here are some of the symbols. So you can see here, this just solid line represents a hard surface of a road. This dotted double dashed line shows an unimproved road. Here, this line with slats going through it is giving you the symbol of a railroad track. So you might see, the line. So these are basically a map. A straight line would represent, a road. Then here you see a line with the word elect, meaning electric. So it's line, elect, line, elect, line, elect. So it's just showing you that this dashed line with these letterings is showing you the pathway of electrical lines that might be underground or overhead. Then you see these shorter dashes. So that's the line indicating of a pipeline. So maybe there's water underground, or maybe there's a gas line under there. So it would be labeled to its type. Here you see a large line with double small dash. Large line, double small dash. So that indicates a property line. So looking at these symbols will tell you what you're looking at in terms of its line. Here's what this circle with the dot in it is called a spot elevation. It's telling you that at that particular point, it's an elevation of 741.22 relative to some benchmark. Here, it's showing you a finish spot elevation. So here, this is what it is, and then here is what you would want it to be at its finished elevation. So maybe it's not at the elevation, the land is not in the shape that you want to be, and you're going to have a tractor take it to that dimension. So you're saying this is where I want my point elevation to be. And this just shows you a property corner with a monument symbol. Here it's showing you what is referred to as an iron pin corner. So there, somewhere in that area, there's a pin or a nail jammed into the ground that you would find to know that that's your corner. And then this represents your benchmarks. So an X could indicate a certain point, a benchmark. And then this triangle represents another benchmark, another measured point. And then these are the symbols for trees. Looking at it from a plot. This is symbols of an elevation where, this will be water. This would be a forest. This looks like ground cover. This is a swampy area. This is a grassy area. Small irregular trees, sand, gravel. Excuse me. When we talk about building locations, outside of the structure is shown on the site plan. And the setback is that minimum distance between the property line. Zoning is the system of classifying the use of development of land, right? It could be commercial land, which is like stores and restaurants. It could be industrial land, which is where you're going to put shops and factories. It could be residential land, which is strictly a neighborhood for people to live with parks and houses. Easements are areas of land marked for use of and maintenance and utilities. Like a road is a utility road, so PG&E can go through your property, or the neighbor can access his property and his driveway and your driveway. You share the same driveway. So you have an easement. You cannot walk that driveway. You have a legal easement, meaning you're giving someone the legal right to pass through only on that particular space. A main utility line are connections. Main utility lines or connections also show on a site plan. So wow, this is a really busy site plan here with lots of information. You can see property lines, you can see streets, you can see multiple lots, their lot numbers. Notice the site plan with setbacks and easements. So all these different lines, like you can see the solid lines represent the plot, the site, and then you can see dashed lines which are just slightly off of the site and that show the setbacks. Here you can see the outline of some buildings and some structures. If this was a larger, easier to read, we'd be able to get more information from it. But this is basically what it looks like. This is an example of a commercial site plan. As you can see, it shows you the outline of the building. It shows you the area established for parking. It'll show you where handicap parking might go, or accessibility sidewalks and pathways. Notice the arrow is probably pointing to true north. See, slightly at that 21-degree angle. And you can see there's a street over here, some roads over here, corner going around the corner, the property on the next street. Lots of information going on here in this commercial site plan. Here's another site plan, commercial. Hard to establish what's going on here. It's just another page. So reading a site plan. So studying the features shown on the site plan will help you become familiar with important information associated with the building project. So yeah, you get out that big old site plan, you need to start reading it. What is this line? What is that line? Oh, this line travels around in this distance. Oh, what are those symbols? Oh, that's a parking. Oh, this is the building. This is indicating underground power. Oh, this is indicating water that's underground. So a site plan shows the land contours, the shape of the land. It's established points of elevations, the changes in heights. It shows locations of utilities and important information about construction. So learning to read a site plan is no different from learning to read other building plans, except site plans include three-dimensional information. Site plans are showing you different elevations and height on a flat piece of paper. So those lines and those numbers are very significant with meaning. Other types of plan drawings, such as floor plans, usually show all features at the same elevation. When reading a site plan, always try to form an overall bird's eye view of the site layout and then focus on the details. So when I'm looking at a floor plan and I see all the different shapes and everything laid out, I expect them pretty much all be at the same height. Like when I see the floor, maybe the floor will change a little bit from one room to another. That's going to be indicated on the plan. Otherwise, I'm going to assume that everything's at the same level. So at this time, take 10 minutes to complete the test your knowledge questions in the textbook. I will publish the answers on Canvas, and you'll be able to check your answers, find out how you did, just to help you test your knowledge and possibly earn a few points. So that's my lecture for this time. Thank you very much. If you have any questions, please reach out to me.